How do you use the side splitter theorem? This is for chapter 7, section 5 out of your textbooks, and we'll answer this question at the end of the video. Here's a reminder of what your notes look like. Chapters 7, section 5 should be up top along with the title of that chapter and section. And then you have, this is the video title number 1. You're going to write your notes, and then make sure you leave room for your video title number 2, which is the next one. So here is the actual side splitter theorem, and it's theorem 7-4 out of your textbook. If a line is parallel to one side of a triangle and intersects the other two sides, so this line is parallel to this line, how do you know that? The red triangles right there indicate that they're parallel, and it intersects this side here and this side here, then it divides those sides proportionally. So this side is proportion over this side is the same proportion as this side all over this side. It's a pretty cool rule that we can use to apply to different triangles. Okay, here are 2 examples for us to apply the side splitter theorem. I'd like you to write down the instructions along with the picture and label everything for both examples. And then when you're ready to, I want you to practice it on your own, try it on your own using the theorem. And then when you're ready to check your answer, resume the video. Okay, look at the boxed answers. Hopefully you were correct. And now let's discuss what I did to get those answers. We're going to use the side splitter theorem since this side splits or intersects this side and this side of the triangle, and this side is also, this line is parallel to this bottom part of the triangle. It makes the sides proportional to each other. So x over 16 is the same thing as 5 over 10. I set up the proportion here. X over 16 is equal to 5 over 10. I use cross multiplication. I got 10x equals 80. Divide both sides by 10 and x equals 8. So that would be the missing length here for x. Then let's look here. We're going to do the same thing. This side is parallel to this side. It didn't have the markings on there, but they are parallel. And that means that this side is proportional over this side is proportional to this over this. So I did x plus 1.5 over x is the same thing as 5 over 2.5. I used cross multiplying, and I got 2.5, and I had to put in parentheses the x plus 1.5 equals 5x. Distribute the 2.5, subtract 2.5x to both sides, then divide both sides by 2.5, so x is going to equal 1.5. And because I was using decimals, I used my calculator, but they're pretty simple decimals to work with. Just a reminder, bring your questions to class, and rewatch the video if you had difficulty with these 2 examples. Here's the corollary, or in other words, another part of the side splitter theorem. Oops, I didn't mean to do that. For the side splitter theorem. This tells us that if 3 parallel lines intersect 2 transversals, so here's 1, 2, 3 parallel lines, and they're cut by 2 transversals, then the segments intercepted on the transversals are proportional. So A over B is the same thing as C over D. These sides become proportional to each other. So the side splitter theorem, the actual theorem, applied to triangles, and now we're looking at some parallel lines cut by transversals, and realize we also have angle pairs within here. So we can apply this to a few different problems. Let's see a few examples that we could apply this corollary to. So here is a triangle, and this is the actual application of the side splitter theorem, the corollary. So given the edges of the panels of the sails are parallel, so we're given that these are all parallel to each other, then find the values of the different variables. So we're looking at these variable x and the variable y. So I'm going to section off the first top part with red, and I'm actually going to evaluate that part first. So by the corollary of the side splitter theorem, I can do proportional sides. So 2 over x is the same thing as 1.7 all over 1.7. And I would cross multiply, and solve that x would equal 2. And then for the black part, I'll do the y's. Same thing, 3 over 2 is equal to y all over 1.7. And if I use cross multiplication, I will get that y is equal to 2.55. So I just used the side splitter theorem and applied it to the sides of a sail to figure out the lengths. Okay, so here I think you should try one. I know I put you want to try one up top, but I'm pretty sure you do want to try one. So here's an example for you to try. We'll discuss it in class, but notice that you need to first find the variable x, and then you'll have to find the variable y. And you're going to use the slide splitter theorem to do this. We'll discuss this example as our stretch in class. Bring all your work.